Cognitive architecture often relies on a standard assumption. The brain operates like a rigid sorting machine, utilizing discrete, localized modules to handle specific tasks. This division of sensation, emotion, and cognition into separate processing buckets struggles to explain the fluid reality of subjective experience. When you perceive a threat, the reaction feels like a single integrated state, rather than a linear sequence of visual processing followed by an emotional trigger. The Brain Kinematics Model, or BKM, offers an alternative to this modular view. Under BKM, cognitive functions arise from a single continuous dynamical process, rather than separate biological systems. Within this framework, consciousness functions as an emergent property of network geometry, defined by the specific organization of active pathways at any given moment. The model begins with the physical substrate of memory unit nodes. These are the relatively stable structures that store sensory data, procedural skills, and semantic concepts. Nodes occupy a wide spectrum of stability. A sensory trace of a passing sound may last only seconds, while core identity structures maintain structural integrity for decades. This single point represents a stable memory unit node. In the BKM framework, nodes organize into a semi-fractal architecture. A parent node, such as the concept of mother, contains specific related subnodes like her face, her voice, or the childhood home. These subnodes branch further into even smaller units of detail, creating a massive hierarchical fractal web. These stable nodes provide the static physical geography, the map where thought takes place. Because this fractal architecture is stationary, it requires a dynamic integrating mechanism to generate active conscious experience. That integrating mechanism relies on links, the temporary components that bridge the gaps between stable memory nodes. These links manifest as short-term memory traces, attention pathways, or active emotional associations that bind disparate nodes together for a brief window of time. While physical nodes are permanent, these temporary links are transient, rapidly appearing and dissolving as information is integrated. The active energy moving through these temporary structures is known as neural strain flow. Here, the dynamic lines represent the links, while the color gradient pulsing across the topology shows the neural strain flow physically traversing the network. As the flow passes through, the nodes expand and glow, signifying a change in their structural load and immediate accessibility. This illustrates the core dynamical rule of the model. The flow changes the network topology, and that altered topology then guides out subsequent pulses of energy. Cognitive activity emerges through the continuous, reciprocal interaction between these permanent nodes and their temporary links. This interaction is not random. The direction of the strain flow is dictated by specific pressures within the network. BKM calls these attractors, temporary directional tendencies driven by biological needs, immediate goals, or overarching themes. In this wider view, the pulses are drawn toward a specific cluster. The attractor acts as a basin, biasing the flow toward a specific state, such as the pursuit of a research goal or the satisfaction of hunger. Activity moves in a phase wave. An external input, a sudden sound or an unexpected sight, strikes the network, disrupting the steady flow into the basin and scattering the active pathways. This deviation from balance forces the system to generate new strain flow, reorganizing the active links into a new, temporary structural balance. The output produced by this balance-seeking process immediately becomes the new input for the following cycle. Brain activity functions as a traveling phase wave seeking equilibrium, a continuous loop rather than a linear input-output chain. The phase wave concept removes the need for sharp boundaries between sensation, perception, feeling, and cognition. Sensation is the raw, uninterpreted input that initiates a localized network strain. Perception is a branching process where that initial strain splits into multiple possible interpretations of the incoming signal. Emotion occurs as a temporal integration. The network simultaneously maps these perceptual pathways against past memories and future predictions to assign value to the stimulus. Cognition is the progressive reduction of this uncertainty. The system filters the competing emotional pathways until a single dominant trajectory remains to guide an action. These stages are varying degrees of topological organization within the same continuous wave, not data being passed between different brain regions. When the system filters these competing emotional pathways into a single dominant trajectory, the result is a stabilized product, what we experience as advanced reasoning. If all thought is a movement of strain flow through a network, what defines the state of being conscious? The BKM defines consciousness as higher-order perception. This is the system's holistic awareness of its own evolving, balance-seeking activity. We can map these subjective conscious states by their geometry within a coordinate system called the strain flow phase space. This graph tracks the phase space across 3 axes: sensory to conceptual, emotion to cognition, and the temporal span between past and future. Deep sleep appears as small, isolated, sparse clusters low on all axes, indicating minimal integration and a narrow temporal window. During REM dreaming, the temporal integration expands. The geometry shifts into wider, fluid shapes that map heavily along the emotion axis. Focused waking is characterized by tight, highly structured pathways that drive high up the cognition and conceptual axes, reflecting goal-directed coherence. These various states of mind, from sleep to focused waking, are specific regions and shifting geometries within this phase space. The human mind is a singular, dynamic topological process, unfolding over memory structures as it continuously seeks balance in an ever-changing environment.